In Section 6.2, we are going to estimate solutions to systems by inspection. So that means just looking at different things. So in this first example, two runners run a 100-yard dash at speeds shown in the diagram. So if you look at the speeds, runner 2 runs 8 yards per second, and runner 3 also runs 8 yards per second. Runner 3 starts 4 seconds before runner 2. Will runner 2 pass runner 3? How do you know? Well, this is a little bit obvious. If they both run at the same speed, and runner 3 starts before runner 2, then runner 2 will never catch up. Make sure that you copy down that sentence before moving on to the next problem. Now let's talk about different types of solutions. When you solve two variable systems of linear equations, we found out on section 6.1 that you're looking for the intersection of the lines. So solving a two-variable system has three possible outcomes. The first is where the two lines intersect, as you can see in this diagram, or in this graph. So right here, the two lines intersect at that point, which means 2, 1 is a solution to the system of equations. That happens if the slopes are different. So if you look at the equation here, the slope of the equation is 1. The equation here, the slope of that line is 2. So a system of linear equations will have one solution if the slopes are different. Be sure to get that copied down before moving on in the video. Another scenario is when you have two lines in a graph, they could be parallel. And if the lines are parallel, then they'll never intersect each other. Since the answer to a system of equations is where lines intersect, this has no solution. Now, let's talk about the equations of parallel lines. If you notice here, the slope of this line is 1, and the slope of this line is 1. They go up 1, right 1, up 1, right 1 for both sets, or both lines. So since the slopes are the same, but the y-intercepts are in two different spots, that means they are going to be parallel. So in our notes, a system of linear equations will have no solution if the lines have the same slope and they have different y-intercepts. Be sure you have that recorded prior to moving on in the video. This third scenario is when you solve two variable systems of linear equations. You could have two equations that actually end up being one line on top of the other. So this line here is actually the line y equals x plus 2, where the slope of the line is 1. So we go up 1, right 1, up 1, right 1, and the y-intercept is 2. So it starts there. Now this other equation in red is not solved for y yet. So if we solve that equation for y, we would have to divide everything by 2. And when I divide 2y by 2, I get y. When I divide 2x by 2, I get x. And when I divide 4 by 2, I get 2. So this ends up being the exact same line. One is on top of the other. That happens if the slopes are the same and the y-intercepts are the same. Now there's a typo in our notes, so we need to fix the typo. We need to get rid of the wording that says no solution, and we need to change that to be infinitely many solutions. So I'm going to add an S there. So infinitely many solutions if the slope is the same and the y-intercepts are the same. Please make sure that you get that written down prior to moving on in your notes. This last page of our notes summarizes examples where there is one solution, no solutions, and infinitely many solutions. So with the one solution, we have this system of equations here. You should remember that x equals 3 is a vertical line, and y equals 4 is a horizontal line. So when a vertical and a horizontal line meet, they will meet in one point. So that has one solution. If you take a look at this example, you should notice that the slope on the top line is 2, and the slope on the bottom one is -1. So since the slopes are different, that means there is one solution. Taking a look at the no solution examples, we have the same slopes, but different y-intercepts. So that means they are parallel lines. Parallel lines have no solution. Now this one, it's not as obvious, so we would subtract x from both sides. So we're going to do some work here. So if I have x plus y equals -1, I'm going to subtract x from each side to get y by itself. So y equals -x minus 1. Now I'm going to do the same thing with the bottom equation. So I'm going to do that one over here. We have x plus y equals 1. So I'm going to subtract x from each side. And that leaves me with y equals -x plus 1. So if we compare, we have a slope of -1. Here we have a slope of -1, so the slopes match. The y-intercept is -1 here, and the y-intercept is +1 here. So they're different y-intercepts, and that's why there is no solution to that system. Third, we're going to look at infinitely many solutions. I'm going to hop down to this one. This one's a little bit easier to see. If I divide that bottom equation, everything in it, by 2, so I'm going to take 2y divided by 2, 10x divided by 2, and 8 divided by 2 to get my y by itself. I have y equals 5x plus 4. And you can see that that's the same equation as what I have up top here, y equals 5x plus 4. So the slopes are the same, the y-intercepts are the same, so that means that they will always touch. One is on top of the other, so that means we will have infinitely many solutions. Now let's take a look at the top equations. So I'm looking up here at 2x plus 3y equals 6 and 8x plus 12y equals 24. This one will require a bit more work. So I'm going to start by getting the y by itself on the top equation. So 2x plus 3y equals 6. I'm going to subtract 2x from each side. And that leaves me with 3y equals negative 2x plus 6. And then I'm going to divide everything I see by 3. So that leaves me with y equals negative 2/3 x plus 2. Now I'm going to take a look at the bottom equation, and I'm going to use the equation 8x plus 12y equals 24. And so I'm going to get the x on the other side of the equation by subtracting 8x from each side. When I do that, I'm left with 12y equals negative 8x plus 24. And then I'm going to divide everything I see by 12. So that leaves me with y equals, and then negative 8 over 12, both of those numbers are divisible by 4, so that simplifies to negative 2/3 x, and then 24 divided by 12 is 2. And once we put them in slope-intercept form, we can see that the slopes are the same, and so are the y-intercepts. So that means one line is on top of the other, and there are infinitely many solutions. So in this Got It, we are going to look at the equations and put them in slope-intercept form. So I have 2x minus 2y equals 8. So I'm going to subtract 2x from both sides to get the y by itself. Keep in mind that when I get rid of that 2x, I still have a negative 2y on the left, and then I have negative 2x plus 8 on the right. Then I divide everything I see by negative 2, and I have y equals x minus 4. In the other equation, I have x minus y equals 6. So I'm going to subtract x from both sides, and that leaves me with negative y equals negative x plus 6, and then I'm going to divide by negative 1, and that leaves me with y equals a positive x minus 6. So this will help me determine how many solutions there are. This has the same slope, different y-intercepts, so that means it's parallel, and therefore there are no solutions. Please read through this part of your notes and make sure it makes sense to you. You can also use logic to understand when there would be no solution. And then we're going to move on. By inspecting the equations, what can you determine about the solutions to the system? So I'm going to notice here that the two equations 3x minus y equals 6 and 6x minus 2y equals 12, I'm going to notice that this is just this equation multiplying everything by 2. So that means since you multiply everything by 2, it's the same equation, and therefore it's the same line. So let's write that down. If we multiply all of this by 2, we get 6x minus 2y equals 12. So that's the same as this. So it's the same line, one on top of the other, and therefore there are infinitely many solutions. Let's take a look at the got it. So this one, we have two slopes that are the same, -6 and -6. The y-intercepts are different. So that means that we have parallel lines. And because we have parallel lines, there is no solution. And that summarizes your notes.